Hi, today we'll be discussing about the authentication header. This authentication header is a security mechanism for authenticating the origin and guaranteeing the integrity of information. That is, it supports data integrity and authentication. Authentication verifies the user identity, and data integrity assures that the data is not changed during the transmission. And also, it prevent the spoofing attack. It is illegally accessing the other person's privileges, impersonating them. So this type of attack can be prevented by this authentication header. It is based on the use of a message authentication code. Here two parties, that is sender and receiver, must share the secret key. The authentication header consists of several fields that make up the complete authentication header. That includes next header, payload length, reserved fields, security parameters index, sequence number, and authentication data. So here, next header that identifies the type of header that immediately follows this header, and the payload is the data, and that length of that data is given in this field, and remaining field is reserved for the future purposes. The security parameter index contains 32 bits, and it identifies the security association between the sender and the receiver. That is a relationship between the sender and the receiver. That association is identified by the security parameter index, and a sequence number. The sequence number that provides the anti-replay attack. And the next one, authentication data, it includes the integrity check value. It produces a code, that is message authentication code, by the MAC algorithms. This figure shows two ways in which IP security authentication service can be used. One is end-to-end authentication, and another one is the end-to intermediate authentication. The first one is the end-to-end authentication. Here the authentication is provided directly between the client workstation and the server. The workstation can be either in the same network or to the external network. They share a protected secret key. The authentication is secure. It uses the transport mode security authentication. And the next one is a end-to intermediate authentication. Here the remote workstation authenticates itself to the corporate firewall in order to access to the internal network. It uses the tunnel mode security association. And the next one is a ESP, that is encapsulating security payload. It provides the confidentiality and also the limited traffic flow confidentiality. Here the format of this ESP is given in this picture. It consists of various fields: security parameter index, sequence number, payload, padding, authentication, data. The security parameter index is a 32-bit information. It identifies a security association, and a sequence number contains 32 bits. It increases the counter value. It maintains the counter value. It provides an anti-replay attack, and this is a payload data. Here the data is protected by the encryption. The padding here, it serves several purposes. If an encryption algorithm required the plain text to be extended, that can be done in the payload area. And the pad length, it contains 8 bits. Number of pad bytes preceding this field, that can be specified here. Next header, it is 8-bit field. It identify the type of data to be continued in the payload data field. The next one is authentication data. It contains integrity check value. Next, combining security association. The security association means a relationship between the sender and the receiver. That can be implemented either AH or ESP, but both cannot be combined. But in some cases, we need to implement both. In that situations, we can make use of these things. That is, we form a security association bundle. Various security associations are bundled here. That is a sequence of security associations through which the traffic must be processed to provide the IP services. It may terminate at a same point or a different point. It can be implemented in two ways: transport or through the tunneling method. The basic combinations of security associations are given here. In the first case, the authentication header is in the transport mode. That is, security is provided between two end systems, host and here. These two end, the security is provided only in this two end systems. That is case 1. And in the case 2, the security is between the gateways. No host implement the services here. And in the third case, it combines the say case 1 and case 2. Case 2 is the security between the end systems, that is also given here. And also in the second case, the security between the gateways are given. So these two cases are combined to form this third case. And this fourth case of security association is the connection between the remote and the internet. So here in remote systems are connected to the internet. Here the security is provided between the remote systems and the gateway, and between the gateway and the host in the local internet. Thank you.